Yeah, here we go. Okay. Okay, so hello everyone, and welcome to today's Gala webinar. My name is Isabella Massardo, content strategist at Gala. Today's topic is a presentation about post-editing in the era of neuro-machine translation, large language models, and artificial intelligence. And the presenter is Viveta Jean, who is one of the moderators of the special interest group on machine translation post-editing here at Gala. You know that the webinar will be recorded. I will follow up with an email containing the link to the recording as soon as it becomes available. We're going to have a Q&A at the end of Viveta's presentation. So please submit your questions either through the chat or the QA box. And I would invite you to do so throughout the presentation as you think of your questions. And having said that, Viveta, I'm going to leave the floor to you.
Thank you very much, Isabella. It's always very nice to have you with me in the webinars. And good morning or good afternoon, everyone. Thank you for being with me today. It's actually one session about the journey from NMT to LLMs. And I was inspired to present you this because back in 2019, I presented a session from translation to post-editing. So I believe that it is good to recap right now what is going on and think a little bit outside the box, meaning that I will try to shape a little bit your thoughts about the new technology and AI translation. So some words about me. I am a PhD candidate in translation at the Ionian University with my supervisor, Wilhelmini Sosoni, Associate Professor. I'm dealing with machine translation post-editing and the contribution of training to the increase of productivity and reduction of effort. In parallel, I'm the founder of the Gala Machine Translation Post-Editing Training Special Interest Group, joining academia, LSPs, post-editors, and this year AI engineers. Probably I forgot someone, buyers. And in parallel, I'm an MTPE trainer and provide translation, copywriting, editing, revision, and transcreation services. So let's start with our agenda. I have 5 topics for you today. We will start with machine translation, post-editing, and neural machine translation. So at some point, we will try to balance the situation, see what we have achieved so far. What is this technology? Because sometimes things are mixed up. And we're going then to make the transition from NMT to LLMs and see what is the impact of LLMs on MTPE. And then we're going to touch HCI, human-computer interaction, a little bit with the best practices right now for the post-editors under this light of new technologies. And in the end, I will present you some latest research about the capacity and the possibilities of AI translation, assisted tools and applications, and the future of MTPE. So let's start with this first slide where I present you the real world applications and the current state. So I have 2 images, 2 charts about the global machine translation market by application. And this is to show you how we have the different industries here expanded in the machine translation, like healthcare, e-commerce, you see electronics, they have a big share in this pie. And another interesting thing is that starting from 2017 until today, we have the machine translation services expanding from 5, for example, providers to 45 today at the commercial level. So this is important to see the evolution of machine translation in general, taking into account that machine translation is very important for all industries because they can have customizable multi-domain translation solutions for all the domains and aspects of their organization business, like e-commerce, customer support, social media. They can cover everything. So saying this, I'm going to start here with the interaction with the poll. And I'm setting this question because I would like to see if we all understand the same thing by AI translation. So the question is, and I invite you to join slido.com, which AI technologies are relevant to AI translation? So let's do this. Okay, so this is activated. So is it NLP, deep learning, NMT, generative AI, NMT and generative AI, or NLP and deep learning? I give you some time for this. Interesting, the results. So what you have said so far is that the AI technology relevant to AI translation is 43% generative AI, 43% NLP and deep learning, and 14% NMT and generative AI. Now it is 25. Okay, let's see. Okay, so let's see the results. It's a difficult question. It seems easy, but it's not. It's tricky. Okay, so I will not share the results exactly. I'm going to say what it is. So you have generative AI 27%, NMT and generative AI 40%, NLP and deep learning 33%. So most of you, 40%, have the correct answer, which is NMT and generative AI. And I'm going to explain why the correct answer is NMT and generative AI and not NLP and deep learning. So let's go back to our presentation. So the idea is that because of this big hype of AI in our industry, we need to go somehow back to the basics. Machine translation initially is a form of AI-enabled translation. So I think we all know what this means. And while I'm explaining the results and everything, I can share with you this video. Let's see if it works. Okay, which explains the basic things about NMT. So in simple words, MT can perform instant automatic translation from one language to another without the human intervention. Now, NMT and generative AI, as you may see here, they go under the umbrella of AI translation. And I precisely highlight this because in different forums or webinars lately, especially post editors, when we talk about AI, it is only perceived as ChatGPT. So machine translation that relies on complex machine learning algorithms using neural networks or natural language processing is known as neural machine translation. So natural language processing is just a technique, and the same goes for for deep learning. They're not technologies. So this is the difference here. Machine translation works by analyzing patterns in large volumes of bilingual data and generating translations based on the probability of certain words and phrases that occur together in different languages. And it imitates the human brain processes and works with deep neural networks. So it trains models for different language combinations and content types. And what is the goal? To produce accurate and natural sounding output. Now, generative AI translation goes further. Older AI translation tools learn from vast amounts of data to improve the contextual understanding of language, resulting in more fluent, contextually appropriate, and human-like translations. Then came along zero-shot translation used by newer AI models like ChatGPT to solve complex problems with little data. So to make a point here, the question is NMT distinct from generative AI? And the answer is yes. While both leverage AI deep learning and natural language processing, NMT aims to produce text translation where the given output matches or maps to the text input exactly. Generative AI, on the other hand, is a broad term and it covers AI systems that can generate audio, code, images, text, simulations, and videos. So this is the difference and the umbrella of AI translation covering generative AI and NMT. So now, what we have seen so far in order to go to the next phase is this picture that you have probably seen with me in previous webinars, which represents the different phases of machine translation post-editing and the use of CAT tools and machine translation in the workflow. So this includes pre-editing, post-editing, and error annotation, where we have the human in the loop, while the rest phases are automated with the combined use of translation memory and machine translation. So the benefits are well known: increased productivity, quality, and reduced cost. And what finally does still remain a challenge? So here about the challenge, I would like your interaction. So we have a question here. What is one of the challenges of MTPE with NMT? Let's answer this question. The poll is activated. So when we work with neural machine translation, this produces an output with some errors, and this goes to MTP. So what is the challenge here? What is NMT's challenge? Less fluency and naturalness of translations, inconsistency in terminology and style, increased post-editing effort, handling context-specific nuances and idiomatic expressions, or reduced translation speed and efficiency. So I receive your answers. Okay, we have 17 votes so far, and 47% go for the answer D, handling context-specific nuances and idiomatic expressions. 29% go with inconsistency in terminology and style, and 12% less fluency, and 17% increased post-editing effort. So not because the other answers are not exactly correct, but I would say that one of the challenges, the main one, is handling context-specific nuances and idiomatic expressions. And we're going to go deeper into this. So the reason that neural machine translation has a challenge here with this aspect is because NMT models often struggle to capture the subtleties and cultural context inherent in such language elements. So neural machine translation relies on patterns and associations it has learned from training data, but it may not always fully understand the cultural or contextual nuances that play a crucial role in accurately translating idiomatic expressions or content-dependent phrases. So this can result in translations that are grammatically correct, but lack the intended meaning or cultural appropriateness. So here in this slide, you can see that the real challenge comes from the translator's voice, and I would like to thank Anna Gerber of our NSD researcher and professor for sharing this in her own webinar. And we see that other challenges are the demand, for example, for computational resources. We see that NMT models, especially those using advanced architectures, they require substantial computational resources, which can limit their accessibility and scalability. We all know that they struggle with low resource languages because there is limited training data, and inflexibility, because how flexible can be a system that needs training and retraining. For sure, it involves a high cost. We have the lack of consistency, especially for large projects. So if we have different terms to translate the same word or phrase, this can lead to confusion and misunderstanding. And it struggles with complex content. So translating, for example, idiomatic expressions, as we said, cultural nuances, technical jargon can pose challenges to empty systems, leading to inaccuracies, which are probably tied to the effort of the machine translation post-editing. And let's see now the benefits of machine translation post-editing. One is the contextual understanding, especially when working in combination with LLMs. So deep learning makes wonders. Neural machine translation systems are adept at understanding the broader context of sentences, and this is how we have more accurate translations. We have speed and cost effectiveness. No one can doubt this. So it can process large volumes of content in a short amount of time, and it is available to everyone, like tools like Google Translate and DeepL. And it excels at standard terminology, so it can easily recognize and accurately translate commonly used terms and expressions, particularly in sectors where there is specific industry terminology. Now, the question for you, because we're going to make the transition, we saw what happened with NMT, what is NMT, what is AI translation, the basics, and now we want to make the transition from NMT to LLMs. I would like to know from you, what is the main difference between NMT and LLMs? So I'm going to activate now our third poll. Now it is activated for you. You can go and vote. And the answers are: NMT specializes in translation between languages, while LLMs have a broader range of natural language processing capabilities. NMT uses parallel corpora for training, while LLMs are pre-trained on vast amounts of monolingual data. NMT focuses on bilingual translation, while LLMs handle multilingual text and perform various language tasks. NMT has language-specific models, while LLMs are more generalized and adaptable. And NMT excels in specific language pairs, while LLMs are versatile across languages and tasks. It's a confusing question again. So let's see. Okay, so I have 13 answers. I will give you some more time for this. Okay, 16 answers so far, 17. Fantastic. I think we have something here. So 41% went for the first one. NMT specializes in translation between languages, while LLMs have a broader range of natural language processing capabilities. And then we have a shared participation for the rest of them, like 18% for the second, 6% for the third one, 18% for the fourth, and 12% for the last one. Now, what is the most appropriate answer? Because all of them contain a sort of correctness inside. So let me share with you. So the most appropriate answer here is that NMT focuses on bilingual translation, while LLMs handle multilingual text and perform various language tasks. And why is that? A large language model, to start with the definition, is a neural network with billions of parameters trained on vast amounts of unlabeled text using self-supervised or semi-supervised learning. These general purpose models, they are capable of performing a wide variety of tasks, from sentiment analysis to mathematical reasoning. So despite being trained on simple tasks like predicting the next word in a sentence, LLMs can capture much of the structure and meaning of human language. And they also have a remarkable amount of general knowledge about the world, and can memorize an enormous number of facts during training. So you can think of LLMs like a giant flexible brain that you can teach it to do almost anything, provided that they have enough data and processing power. So here you see on this slide that empty models and large language models, they have some things in common. They are based on transformer architecture, but empty models go for one task, which is specifically machine translation, while large language models, they are trained on large text bodies, and they can go with more tasks. So it can be summarizing, it can be text generation, it can be many things, translation, etc. So one is for generic content, let's say it works best, and the other works with prompting. So here we have the engineered prompt concept. And one goes with customization option, meaning that we can customize empty models and do this for the tone of voice, the vocabulary, the terminology, while large language models guide us to the personalization option, where we fine tune the model and using context learning. So these are the differences that guided us to this correct answer. Now let's go with some history, a very short one, because I know that maybe this is just to show you the journey of it and to compare it with machine translation. So if we say that machine translation started in the 40s, here we see that the journey for LLMs started something like 15, 20 years after. So it is in 1967 that we have the first chatbot, Eliza. And then in 1997, we have the introduction of the long short-term memory. In 2010, we have Stanford and a set of tools and algorithms for complex NLP tasks, sentiment analysis, and named entity recognition. And then in 2011, we start to understand the context of words. In 2017, here we are with the transformer models and the foundation of ChatGPT, which leads us to 2020 with OpenAI and GPT. So saying that, today we have applications of large language models that more or less you all know, which is the involving conversational AI, meaning that we have these dialogue sessions with ChatGPT in practice. Then we have textual content creation. We all have tried these to generate text in various forms, articles, product description, or even creative writing. Understanding sentiments within text, this is a little bit different because LLMs have been shown to perform well in sentiment analysis tasks with applications in customer feedback analysis, brand monitoring, and social media analysis. And of course, we have efficient machine translation here with LLMs behind, and we go a little bit away from the traditional approach, and with the advent of LLMs, translation systems are becoming more efficient and accurate. So something remarkable here, maybe you already know it, but it's good to highlight it, is that one of the most remarkable examples, I would say, of LLMs being used for translation is, of course, Google Translate. But the important thing is that Google has been using neural machine translation models powered by LLMs since 2016, which means that it's not something completely new. It's just a trendy term today. So let's go now and check machine translation post-editing and large language model post-editing. Machine translation is still valid as a quick and cost-effective way to translate large volumes of non-critical content. But if you need more accurate, contextual, and on-brand translations, then maybe AI translation is your best bet. And some language professionals are already using a combination of machine translation, generative AI, human translator, post-editor in the loop, depending on what they are translating. So this is the case right now. And let's see the benefits of post-editing with LLMs. So here we see that one is comprehensibility, because LLMs tend to produce translations that are grammatically correct and easy to comprehend. Adaptability, because LLMs are well equipped to handle a broad range of topics and language styles. And improvement over time, which I feel it is the most impressive here, because LLMs continue to learn from user interactions and the broadening corpus of text, and their performance can improve over the time. Now, challenges of it. You see that we have like 6, there are many. So one is domain-specific translation. So large language models like GPT-3, they're trained on a vast corpus of general text. And however, when it comes to translating text from specific domains, technical, scientific, then they struggle due to the lack of specialized training data. And then we have limitations on the availability of language pairs because LLMs are often trained on a large number of language pairs, which can dilute their proficiency in any specific pair. Contextual understanding is another challenge. LLMs have a decent understanding of immediate context, but they often fail when it comes to understanding larger or implicit context within a text. And this can lead to misinterpretations and inaccurate translations. Idiomatic expressions, here they struggle with this kind of expressions and slang. And quality control and consistency, because LLMs generate translations based on probabilistic models. So there is a degree of unpredictability in their outputs, which can lead to inconsistencies in the translation. Finally, lack of cultural nuance, and they fail to capture the cultural nuances and idioms that are unique to specific languages or regions, like Spanish, Latam, Spanish EU, French Canadian, friends you, and so on. And how does this affect now the machine translation post-editing? What types of translation errors are produced? I was discussing with Isabella before the webinar starts that so far we have not classified the errors coming from LLMs. We're still working on NMT. I mean, not at an extent. So here I can say that we have inaccurate translations. LLMs produce inaccuracies despite their extensive training on vast amounts of data. Contextual misinterpretation, but let me share an example about the inaccuracies first, the inaccuracies. So for example, let's say that we have the word bank, which, as I saw in another webinar, it may refer to a river. And then we have the financial domain, and we have again the word bank, the term bank. And in this case, it is also translated as a river bank. So these are a sort of inaccuracies happening from LLMs. And then contextual misinterpretation. We encounter challenges in grasping the contextual nuances of a text, like we said. So this can be somehow challenging, for example, when we have a speech of a leader, for example, and there is a sort of irony, sarcasm, and if this is not conveyed correctly in the target language, then we see that we probably have a serious issue. So in communication. So bias translations is another one. We know about bias and cultural stereotypes. LLMs may inadvertently reflect and even amplify those biases in their translations. For example, let's say it depends on their training. So let's say that an LLM is trained on a data set that associates doctors with males and nurses with females. Then in this case, it's going to produce translation with bias. And an example would be me translating, for example, the sentence, he's a doctor as she's a nurse, and things like that. Then we have the deep fakes. For example, LLMs can show people doing things that they have never done, to put it in simple words. We all know about the ethical aspects, privacy and data security. Here, for example, it can expose the data to potential breaches or unauthorized access. And the legal and regulatory compliance. So this may include misinterpretation of contracts, legal documents, medical instructions, leading potentially to legal disputes, compromised patient care, or non-compliance with the regulatory standards, just to mention some of the errors. So what can we do now? Let's go to the practical aspect and think about the best practices. The best practices right now is not like guidelines and rules about how to use AI, but I would say I would go one step before that and focus on the training of people and the human-computer interaction about how they should be trained to use these tools. So now, from the university, because we also have to cover this part, and also we need to give a direction to the linguists probably being with us today. So we focus on the specialized translation domains and creative translation as tools, and the AI translation, NMTs, LLMs can deal with generic aspects of language. Then it's best if we are translators specialized in a domain, or we cover what translation technology cannot cover so far. So this is one point here. Then providing depth exploration of AI-based translation technologies. It is time to move beyond conventional applications like translation memories and term bases. And it is important for the linguist to know more about neural networks, attention mechanisms, effective prompting, AI translation tools and their inner workings, in a sense that they will be more efficient in the editing of the output coming from this AI translation. So this is the trend for the future, to get trained in more and be the experts and master our technology and the advances in technology. Along with that, I would say that if we can enhance our programming and computational skills even better, so a knowledge, a basic knowledge of Python, of popular machine learning libraries and frameworks, data preprocessing, and automatic evaluation are modules that probably we should touch a little bit right now, because this programming education will enable translators to better understand the limitations of existing tools and build new solutions tailored to their needs. Now, the basic for machine translation post-editing and the post-editors is to focus on reviewing and editing translations. It is important to emphasize and focus on the errors produced by the translation, by LLMs and the NMT, and also to target develop post-editing techniques to target typical AI errors and strategies for verifying and improving AI translations using official sources and parallel text. I think that the most important part of this presentation and the focus right now in our industry is the AI-assisted translation tools. So if I have something to share with you today, is that we should all be able to consider LLMs as AI assisted translation tools, and not as technology on its own right now. So context-aware suggestions is one of the uses, where AI algorithms analyze the context of the content and enable more accurate and contextually relevant suggestions during post-editing, so translators can make informed decisions. Consistency and terminology management, where AI-powered translation tools help maintain consistency in terminology across documents, and translators get suggestions from the AI. Quality assurance in the same direction, where AI translation tools flag the different errors so we have better quality. Adaptation to specific domains, because AI can be trained to specialize in specific domains, legal, medical, or technical translation. And translators can leverage domain-specific AI models to enhance their expertise and tackle complex documents more efficiently and effectively. Customized translation engines. So here we can fine-tune our own translation models and specialize in niche fields, with the result of more accurate and tailored translations, and productivity and scalability, because we get rid of all the repetitive tasks, we automate them, and we have more time to focus on the real issues. What are the ethical aspects now? Because there is a lot of discussion about ethical aspects. So privacy in MT using LLMs aims to mitigate these risks by developing privacy-preserving methods that can protect the confidentiality and integrity of the translation process. This is what is the research trend right now. So one basic approach to preserve privacy in MT using LLMs is to anonymize sensitive information in the textual input and then pass it to LLMs and get the output, which is then de-anonymized. However, it also has challenges, because this creates enough noise or distortion to the translation output. And another challenge could be the interoperability and compatibility of privacy-preserving methods across different languages, models, and platforms. Now, I'm going to share this image with you, which is from a research, and I'm going to explain in the next slides. It's the research actually from Luke, Xu, and Wang, and about new trends in machine translation with large language models. And I also attended a later interview, I think it was of Wang, not to be mistaken, about this topic, and their work is excellent. So I was inspired to present you the future of PE and the advances of LLMs. So what is the future? What are we going to do with LLMs? What are the applications? Using translation memories as prompts is a promising approach to in-context learning of machine translation models. So how do TMs become better translators? LLMs understand prompts and is indeed helpful for making better use of TMs. So the experiments show that the results of a pre-trained LLM translator can be greatly improved by using high-quality TM-based prompts. And these results are even comparable to those of the state-of-the-arts NMT systems, which have access to large-scale and domain bilingual data and are well tuned on the downstream tasks. Now, you can see that another advantage is the evaluation of the quality of MT using LLMs. So the new evaluation paradigm uses LLMs for more accurate and efficient evaluation of MT systems from various aspects, instead of only evaluating the similarity between system outputs and references. And where do we go? What is the direction right now for the future? With the advancements in LLM-based MT, the focus can be shifted towards personalized MT. And this approach can enable the provision of customized translations that are tailored to its users' preferences and needs. So we have users' language proficiency, domain-specific terminology, or cultural references. And one possible approach to perform personalized MT is to prompt LLMs with user-specific preferences or metadata, such as social media posts of the users. However, personalized MT still raises several challenges, and one is how to collect and store user-specific data in a privacy-preserving manner, and another one is how to measure the effectiveness of personalized MT. Another direction is multimodal MT. So this is promising. It involves integrating visual, audio, or other non-textual information into the translation process. And it can enhance the quality and accuracy of translations in various settings, image, video captioning, automatic speech recognition, sign language translation. So again, there are challenges like data heterogeneity, unbalanced data sets, domain specificity. And we cannot talk about the future without touching the bias and the gender specific MT with LLMs. So LLMs offer a unique advantage. It is the ability to control the properties of the output through prompts. And in a recent study, researchers harnessed this flexibility to explore Llama's capability to produce gender-specific translations for languages with grammatical gender. And the results were really good and not better, actually, than the ones of the NMT models. but LLMs can handle a wide range of NLP tasks beyond producing translations, and this is important, making them valuable tools for translators. So you can see the versatility of LLMs as advanced assistive tools for translators, and this is where we go. They can function as interactive editors. They can suggest edits, modifications to translators' drafts, facilitate human-in-the-loop collaboration. They can produce draft translations from scratch. They can provide explanations for expressions in the source or the target language, and offer multiple alternative translations for consideration. So this feature contributes to a more efficient and effective translation process, allowing translators to focus on complex, nuanced translations and delegate repetitive tasks to their AI collaborators, we would say. This is a sort of human-computer partnership that paves the way for a mutually enriching translation experience. So what is the impact on the translation workflows? It is customization. These are the magic words: customization of both LLMs and NMT, and fine-tuning. When we talk about domain-specific knowledge, by training LLMs with data from a specific domain or industry, legal, medical, or technical, the model becomes more familiar with this kind of terminology, and this means that the LLM generates more accurate translations within that specific area of expertise. Then it can be trained in a specific, they can be trained in a specific task to improve the performance. And they can be trained in a data set, for example, of similar customer support conversations. So this is one of the uses. Adaptation to company-specific data. This is important for the industry. This customization ensures that the LLM generates translations that are consistent with the company's brand voice and requirements. Improved context awareness. Fine-tuning allows the model to become more context-aware in specific translation scenarios. Reduced bias, as it provides an opportunity to address biases that may exist in the model's default training data. And finally, LLMs represent a force of potential disruption within the translation industry. They continue to evolve to become more accurate, and this will lead to an uptick in automation and the push translation and localization upstream in the content supply chain. So here we are. This is all I had to share today with you about the transition, let's say, from NMT to LLMs, which is more of a collaboration in the end between technology and human, as always. It is a transformative journey. The importance of post-editing is still there. We need to continuously learn and adapt to the technology advancements, and continuously explore and embrace innovation in language technology. So I would like to thank you very much for attending today. I'm going to have your questions for this topic. Next week, we have the continuity of this one. We have the second part, which is with Cristina Anselmi and Fernando Velasco, about how to improve quality, cost, and turnaround times in game localization. And if you are interested in the topic of machine translation post-editing training, we go ahead this month. I think it's going to be finally 16th of October with the revamped MTPE training special interest group. Joined by Lucia Guerrero and all of our group moderators, where we will update the machine translation post-editing training protocol. It's not a webinar, it's a call, it's a meeting. So we have our members, we have interactive discussions, and I will be happy to have you with us. So thank you very much. If you have any question, you can send me an email to my institutional email, follow me on LinkedIn. I will be happy to continue the discussion and hear your concerns about the future. So I'm ready for your questions. Thank you.
Thank you so much, Viveta, for this extremely thorough presentation. I can't find another word for it. Thank you so much for all the work that you've done in preparing for this presentation. For those of you who are interested, I put the link to the Common Machine Translation Post-Editing Protocol that Viveta and the post-editing special interest group developed in the last 2 years, and she promised me that they are going to update the document. So I'm really looking forward to see what's going to become. If there are any questions, please write them in the chat, or even better, you can raise your hand and I'll open your microphone and you can speak directly to Viveta. I see lots of cheers, great presentations. Thank you, Viveta.
Thank you very much.
Okay, let's see. Just give it a minute to see whether someone, and I see a lot of thumbs up coming in also on my screen. Mayra says no questions, so everything's clear. All right. So as Viveta said, there's going to be a second part to this webinar, which is going to be next week. And Viveta will be joined by Cristina Anselmi and Fernando Velasco from Electronic Arts. So they're going to take the discussion a step further. And the special interest group, of course, starting very soon. Let us know if you're interested. And talking about AI, we also have opened the registration for our Q4 Academy event, which is on terminology management. And one of the sessions is focused on AI for terminology management. So I'll include the link in my follow-up email. Brahim says, this will need some digesting and brainstorming, hoping we'll get questions next week. Okay, we're going to take you up on your word, Brahim. We'll see you next week then to the second part of this webinar. All right, so there are no questions. So Viveta, thank you so much again. And everybody, thank you for attending. And when I close the webinar, you'll see a post-webinar survey. A post-webinar survey. So please take a couple of seconds to fill it in. Let us know what you think of the content of this presentation, whether you had other topics, AI related or not, that you would like to see features in our webinar program. And I hope to see you very soon at another gala event. Thank you. Bye, everyone.
Bye-bye. Thank you.